This first unit that we are going to be going through is really just a number of different topics that we want to make sure that you have a good solid foundation before we get into more topics and build up to some more difficult topics. So some of this will be new, but most of it will hopefully be a lot of review for you. Today we're going to talk about systems of linear inequalities. Now this is a topic that you have done before in the past in Algebra 2. We are going to kind of take it one step further and look at different types of things we can do with these inequalities, and again, all of this is in preparation for pre-calc, in preparation for calculus, and working with equations and inequalities in a way that perhaps you haven't before. So here's our example. We are going to be starting with a system of inequalities, and then there are going to be a number of different things we're going to do with them. So we have this system of 3 inequalities, and we are going to graph the solution to the system. Now I'm going to use different colors just so we can differentiate here. We'll start with x is greater than or equal to 0. So normally when you graph these inequalities, you want to graph the line and then figure out where to go about shading it. Now because all of these have greater than or equal to or less than or equal to, these are all going to be graphed as solid lines. So x is greater than or equal to 0. That is going to be a vertical line going through 0 on the x-axis. So this is what this looks like. And since this is x is greater than or equal to 0, we want to shade the side of this line where your x values are greater than or equal to 0. In this case, that would be the right-hand side. Now for other types of lines that aren't vertical or horizontal, which are usually easier to figure out where to shade, you may have also done the trick where you pick a point, and then if that gives you a true statement, then you know that you shade on the side of that point. We'll take a look at the next one. So x plus 3y is less than or equal to 18. We move the x over to the other side and then divide everything by 3. So we end up with y is less than or equal to negative 1/3 x plus 6. Now let's go ahead and graph that line. So this is a line that has a y-intercept at 6 and a slope of negative 1/3. So here's that line. Now we need to figure out where to shade on this line. So an easy point that you can use is 0, 0. So if we put 0, 0 into this inequality, we have 0 is less than or equal to 0 plus 6, so 0 less than or equal to 6. That is a true statement, so I will shade on the side that contains 0, 0. All right, next, x minus 2y plus 2 is less than or equal to 0. Let's get y by itself, so we are going to subtract the x, subtract the 2 over. We're going to divide by negative 2. Don't forget, when you divide by a negative number, you are going to need to switch the inequality. This also applies when you multiply by a negative number as well. So y is greater than or equal to 1/2 x plus 1. That's a line with a y-intercept at 1 with a slope of 1/2. So here's that line. And then again, we can use that trick where let's use 0, 0, plug that in. We have 0 is greater than or equal to 0 plus 1. 0 greater than or equal to 1 is not true, so I'm going to shade on the side that does not contain 0, 0. Okay, now there's a lot of shading going on here, but the place where all of the shadings intersect will be our solution. So that would be this triangular section right here in the middle. So I'm going to take away the rest of the shading, and that's the part that we're left with. Okay, part B, determine the vertices of the region formed by the solution. So we have a triangle for the region for our solution. And so we just want to know where those vertices are. This is just mainly to help us with the next parts. So at 0, 1, 0, 6, and 6, 4. Now we're going to determine the area of the region. So since it's a triangle, we know to find the area of a triangle, we can use the formula 1/2 base times height. In this case, we can look at this as a triangle on its side to get the base and the height pretty easily. Remember that the height must be at a 90-degree angle with the base. So we can say that this is the base of 5, and it has a height here of 6. So we can plug those numbers in. We have 1/2 times 5 times 6, which is equal to 15. So the area of this region is 15 units squared. Now let's do the perimeter. Now the perimeter of the triangle is a little bit trickier, but we do have some information on different dimensions in the triangle. So for example, here that's a length of 2, here to here that's a length of 3, and then we know that the height is 6. Now since we want the perimeter, we need to know what the lengths of the other sides of the triangle are. So we can actually use the Pythagorean theorem in order to determine what those lengths are. So at the top there, we can do 2 squared plus 6 squared, and that will give us c squared, which will be the square root of 40 once we solve for c. And do the same thing with the triangle on the bottom. So 3 squared plus 6 squared gives us 45. So c is equal to the square root of 45. So to determine the perimeter, that would be 5 plus the square root of 40 plus the square root of 45. Now you can simplify that down to 2 root 10 and 3 root 5. Now if you wanted to get an approximate answer and actually add those up, that's fine. But if you're asked for an exact answer, you should leave your answer just the way we have here. Now let's work with this triangle and do some things with it within this coordinate plane. So let's see how that triangle is attached to the y-axis. What we're going to do is we are going to revolve this triangle around the y-axis, and then we are going to sketch the solid that's formed on the graph in part A. So take this triangle. I like to have kind of the widest part of it, so this part here. And as this gets rotated, so obviously if you reflect it, that can help you draw it, but we want to think about it more in terms of a rotation around the y-axis. And so if you were to imagine that point at 6, 4, rotating around the y-axis, you'd end up with a solid that looks like this. And you can see by looking at this that we have what looks like 2 cones, and the bases of the cones are attached to each other. Okay, so now let's determine the volume of this solid. So as I mentioned before, it looks like 2 cones, so we're finding the volume of one cone and adding it to the other. Now the volume of a cone is 1/3 pi r squared h. And so now we can plug in what we know. So the radius here is 6 for both cones. And then the height of the cone on top has a height of 2, and the height for the cone on the bottom is 3. We're going to leave our answer in terms of pi just to leave this to be as exact as we can. So this would be 1/3 times 36 times 2, which is 24. And then 1/3 times 36 times 3, which is 36. So 24 pi plus 36 pi. Add those two together, and that gives us 60 pi units cubed, because this is a volume. And that's our exact answer. Lastly, we are going to determine the surface area of the solid. Now when we're looking for the surface area here, you'll notice that because the bases of both cones are attached to each other, that part's actually not part of the surface of this solid. So really what we need to find is the lateral area of the top cone and the lateral area of the bottom cone, because neither of those bases are exposed. So the lateral area of a cone is pi times r times L, where L is the slant height. Now in both cases, the radius of the cone is 6. Now what is the slant height? The slant height is the measure from the top of the cone to the edge of the cone. And so we've actually already calculated that length. We calculated it when we calculated the perimeter of the triangle. So for the cone on top, that was the square root of 40. And for the cone on the bottom, that was the square root of 45. And now we can multiply this. So we have 6 pi root 40 plus 6 pi root 45. And then we can simplify each of those radicals to be 2 root 10 and 3 root 5. So this comes out to be 12 pi root 10 plus 18 pi root 5 units squared. And again, this is giving the answer as an exact answer rather than an approximate answer. If you wanted to give an approximate answer, you can simply multiply and add those two together and get a more approximate answer.